Well, hi guys, we're doing some more operations on surds, and this time we're adding and subtracting surds. These absurd little surds are going to give up without a fight once we're finished with them. So let's get on the attack and have a great time together. Now, when adding and subtracting surds, you basically must simplify them as much as possible first into their simplest possible form, getting all the get out of jail free little beasties out of from under the surd signs, getting them in their simplest possible form, and then you add and subtract the like terms. That's what you do, the like terms, okay? And what makes them alike or not alike is what's under the surd sign, okay? If it's a root 2, it's different from a root 3, if you get what I mean. I'll show you. Some examples for you. Okay, we've got this one. That looks reasonably okay to me. We've got that one. Now, there's going to be some simplifying needed for that one, okay? And that looks absolutely disgusting, okay? But we will conquer together, okay? Let's go. Here's number A. Now, we've got 4 root 6 plus 17 root 6 minus 5 root 6. Now we have to simplify this first, guys. That's the rule. Do you see the rule up there? Got to simplify first. Yes, number 1. So let's see if we can simplify. No, well actually 6 is just 2 by 3. And that's a prime number and that's a prime number. So look, there are no other factors anyway. No repeated factors. Nothing that we can pair off to get out of surd jail. So I think that's it, isn't it? Yeah. No pairs possible. So therefore, root 6 cannot be simplified any further, and we will now just proceed to add and subtract the like terms, which are going to be the root 6 terms. So if you add 17 and 4, they're on the plus team, you get 21 root 6, and then you have 5 root 6s on the negative team. So the pluses do battle with the minuses, and which one wins and by how much? We know, don't we? Basically, we've got 16 root 6, and that's going to be our answer. How marvellous. Okay, good. You get it? Great. Let's do B. Now, this one here, as I foreshadowed, there's going to be some simplification throughout the nation with this one, because that root 12 has got some simplifying, some little beasties in there which don't belong, and the same thing with the root 8. The root 2 and the root 3 are all right, but let's go and see what we've got. Simplifying first. Now 12, as you well know, ladies and gentlemen, is 2 times 2 times 3, isn't it? That's in the simplest prime factors, which is what we do when we do factor trees. So that's basically 2 squared times 3. You see how I've paired them off? So therefore root 12 would be the square root of 2 squared times 3. Now I can get the 2 out of square root jail, and it's 2 times root 3. Yes? Good. 2 root 3. Now what about the, sorry, 3 times root 12, which is what appears up here, see? That's only, this bit's only the root 12, right? Don't forget the 3 times it. So therefore 3 times root 12 is going to be 3 times 2 root 3 from the line above, which will get us 6 root 3 for you and me, okay? That's that one simplified, okay? Good. Good show. Give him a nice tick. Now what about the next one? Yes, that's going to be root 8. So 8 is 2 times 2 times 2, right? 2 2s are 4, 4 2s are 8. You get it? Now let's pair them off, the pairs. 2 squared times 2, and therefore root 8 would be the square root of 2 squared times 2, which would get us 2 root 2. That's 2 squared gets out of square root jail, yes? And leaving the other poor 2 stuck in there. So therefore, we know that that's 2 root 2. Therefore, now look at the original question. We've got 3 root 8. So 3 root 8 would have to be 3 times 2 root 2, which would get us 6 root 2. And we get a tick for that one too. Jolly good show. Now, we're in a position to add and subtract our like terms. And I'm going to colour code them for you so you won't make a mistake. So we've got 4 root 3, they get blue today, and the 6 root 3, then the root 2s get coloured green. So you can see they are different. That is what makes the term, that's what makes it a like term or not a like term, what is under the surd sign. Okay? Yes. So what have we got? How many root 3s have we got? Come on, you do some work. Yes, 10 of those. And what about the root 2s? Looks like we've got 6 on the plus team, 5 on the minus team. Which team wins and by how many? That's right. And that is the answer, ladies and gentlemen. How did you like that? Yes, it was pretty good, wasn't it? I know you're getting better at this now, so that's really great. Now, let's tackle this beastly-looking catastrophe up there in Part C. We won't freak out, we'll just do it step by step. In fact, inch by inch, anything's a cinch. Mile by mile, it's a terrible trial, so we're not going to do it that way. Let's take the first term, shall we? We'll simplify first. Take the first term. We'll just take them term by term, whittle them down little by little, or inch by inch. I reckon with that first term, let's do the 100 first, and then we'll do the pronumerals after that. So we know that 100 actually, to cut a long story short, is just 10 squared, which is a perfect square, isn't it? So therefore, root of 100 would be the square root of 10 squared, and that 10 squared gets out of square root jail just as 10. Well, that's pretty handy, isn't it? Alright, so that's good. Now we'll do the next bit. A squared b cubed, right? Now, let's just see what we've got there. We're going to pair them off, aren't we? So the a squared is already a pair. The b cubed can be turned into b squared times another b to the 1, can't it? That pairs them off. So that's going to be a. The a squared gets out of square root jail as an a. The b squared gets out of square root jail as a b. And the poor old b to the 1 stuck in there. So that becomes ab root b. Okay, for you and me? Right, hence the first term is, now remember there's a half there, there's a half up there, you've got to worry about the half now. It's a half times the 10 times the ab root b. Yes, which is going to be 5 ab root b. Now that's as simple as you can make it, guys, and it's looking pretty good to me. That's the first term done, right? We fixed him, didn't we? Now, what about the second term? Alright, well, let's do the 36 inside the square root sign. That's about all it's going to simplify in there. So the 36 is 6 squared, which is a perfect square, and that's very good. So we got root 36 gets, the root of 6 squared, and the 6 squared gets out of square root jail as a 6, and therefore the second term is going to be a, have a look, a times b squared times what? 6 times what? Root a. Yes, root a today. So you get 6ab squared root a. That's the second term. I know. Don't worry, we'll get there, okay? Third term, right, that one looks, oh look, we're getting to be old hands at this. No problem, let's do the 36 first. We know that's 6 squared, so the square root of 6 squared is just 6. That takes care of that. Now, under that square root sign, we've also got a squared b. Now, you know which one's going to get out of jail and which one's going to be left. Come on, you can tell me, can't you? Of course you can. The a gets out, the b's stuck, right? So you get a root b. So therefore, the third term is the 6 times the a times the yes, and I forgot the 5. Just a minute, I'm going to pause the video. Yes, I was a silly sausage. I forgot the minus 5 up here. Okay, to keep us alive. It certainly kept me alive, didn't it? So up there, I forgot that minus 5. So I've just got it down here now for you. I got it down there, right, and everything's good again. So I got what's that come to? That comes to minus 30. Minus 30a root b. Now we're going to add and subtract our like terms. Now remember, what makes the thing a like term or an unlike term is what is under the third thingy. Okay? Do you get that? So here we go. I'm going to colour code them again. We've got the first term. The first term was up here. Okay? That's going to be 5ab root b. And I've colour coded the root b to show you that this is a root b beastie, right? Then we got basically, from the second term, we got 6ab squared root a, didn't we? And the third term was minus 30a root b, right? Now what you can do, ladies and gentlemen, is, even though all this horrible symbols everywhere, the 5ab just represents some particular number depending on what a and b are, and this is also a root b term over here, so that's minus 30a times root b. So you can combine that and you can say, well, altogether, how many root b's have we got? Well, we've got 5ab of them over here, and we've got minus 30a of them there, okay? So you can just kind of combine those very easily, and you can say, well, it's 5ab minus 30a of the root b animals, yes, plus we've got 6ab squared of the root a animals. How's that? Yes, I think we did it. Of course we did it. And you're a star, and you'll go far. So that's how you do addition and subtraction of surds. You simplify them first, and then you do the addition and subtraction of the like terms after that. Okay? We'll see you in the next video. Bye for now.